Let's see now arithmetic add instruction. Here I am taking data in accumulator, move a comma hash 30. Now I am adding accumulator comma immediate data. Okay. Now let's see what will be the result of addition. Here a contain 30 and again I run this code. Now add a comma 02 means 30 plus 2 is 32. Okay, you can see that the parity bit is changed. Okay, also we can write move r0 comma hash 0 x 30. Now if we add accumulator comma r0, let's see what will be the result. Here you can see that r0 contains 0 and a contains 30 due to this instruction. Now due to this instruction add a hash 2, a contains 32 because 30 plus 2 is 32. Now again if I run this code, now due to this instruction r0 contains 30 and if I again run this code, now add a value inside a plus the value inside r0. r0 contains 30 and a contains 32, so the output will be 62. Okay, again there is one more instruction, that is ADTC means add with carry. We can write add with carry a comma some immediate data or any register, suppose r0. If any carry generated due to previous instruction, that will be added with the accumulator plus the value inside r0. Okay, now let's see subtract instruction. SUBB subtract with borrow. Write SUBB subtract with borrow a comma any immediate data. I will take 2. Let's check the result. Here you can see that a equal to 0. When I subtract this 2 from this 30, the output become 2e. Okay, so this is the arithmetic add and subtract instruction. You can also subtract accumulator with the data inside a memory. So for that we have to write at the rate r0, and first we have to move some data at r0. Move r0 comma .30. Okay, and move at the rate R0 comma A. Now let's check what will happen due to subtract A at the rate R0. Okay, due to this instruction A contain 30, you can see here, and if I again run this code, then 30 minus 2 is 2e. Now this due to this current instruction R0 contain 30, and due to this instruction move at the rate R0A, the address 30 contain this value. Let's see here, D semicolon X. Okay, you can see that memory location 30 contain 2e. Now if I again run this code, so due to this instruction sub at the rate R0, previously A contained 2e and the memory location 30 contain 2e. So when we subtract 2e minus 2e, accuracy becomes 0. You can see here.
Let's see multiplication and division in 8051. Okay, for multiplication and division we require accumulator and register B. So take one data in accumulator and another data in register B. Move A, comma, suppose direct data, if we will take uh, direct data 03, okay, 0x, and if we take the data in B as 0x 03. Now multiply this both register mul AB. Now build this code. Let's see the output. Register A and register B. We have to check register A and register B. Okay, here register A and register B contain 0. If I run this code, then register A contain 3 due to this instruction. If I again run this code, then register B contain 3. If I again run this code, then due to AB means multiply A with B. Multiply 3 by 3. 3 into 3 is 9. So A contain 9. Let's see one more example. If we take FF in A and FF in B and multiply these registers. Now compile this code, run it. Let's check the result. Now run first run A contain FF, in second run B contain FF. Now multiply these both. When we multiply, due to this instruction, A contain 01 and B contain FE. Lower byte is stored in A and higher byte is stored in B. So this is the higher byte and 01 is the lower byte. Okay, so this is the multiplication operation. Let's check about division operation. If we divide A by B, let's see what happen. Okay, where is the register here? First A contain FF, again B contain FF. Due to multiplication, A contain lower byte and B contain higher byte. Now due to division, A contain 0 and B contain 1. Due to div instruction, quotient is saved in A and remainder is saved in B.
Okay, let's see the increment and decrement operation in 8051. Okay, here I am writing move A, comma, direct data, hash immediate data, hash 20 h, and after that I am writing inca. This instruction increment the value inside the accumulator A. Okay, let's compile this code and see the output. Here you can see that accumulator contains 0. Okay, if I run this code, then now move A comma 20h, moving the 20h data to A accumulator. Now A contains 20. Again, if I run this code, so A contains 21 because increment A means the value inside A should be incremented by 1. So A contains 21. Okay, now see what happens if I decrement A. Decrement A. Okay, now compile the code and run it. Now you can see that A is 0 first. If I run this code, A contains 20. Again, if I run this code, due to increment operation, A become 21. If I again run this code, due to decrement operation, now A become again 20 because decrement the value inside the accumulator. Again, let's see uh, if we take data inside a register and increment it. So move r0 comma hash 40h. If I increment r0 and decrement r0, what happened? Let's see. Compile the code. Let's do it and run the code. Now see here. First of all, r0 contains 0. If I run this code, so r0 become 40. Here r0 become 40. Now if I again run this code, in increment r0, due to increment r0, the value inside r0 incremented by 1. If I again run this code, due to decrement operation, the value inside r0 is decremented by 1. So now r0 contains 40. Let's see how to increment and decrement a DPTR. Okay, for that we have to take data in DPTR, move DPTR comma hash 50h. If I increment DPTR, now compile the code. Okay, program size data. Okay, this is the correct. Now run this code. Let's see what is inside DPTR. Here DPTR contains 0. If I run this code, due to move DPTR a comma hash 50, DPTR contain 50H. Okay. If I again run this code, now due to increment DPTR, the value inside DPTR get incremented by 1. Okay, so DPTR contain 51. Let's see, can we decrement the DPTR? If I write decrement DPTR and build the code, it gives